this video introduction to the IFI, the Industrial Fastener Institute Technology Connection website. It's a resource that's accessible through the SB website. It's an extremely good resource for design engineers to make custom specifications for the parts that they're developing. They can download those as PDFs, they can share them with colleagues, they can get them to purchasing to procure. So the RFI Technology Connection has very good resources on converting different materials from across the world, information on fastener weights, how to inspect fasteners, testing of fasteners, application, and a wealth of a technical library in the IFI Technical Bulletin section. So one of the most common issues design engineers face in selecting fasteners for an application is viewing the relevant standards which govern the part. Often engineers don't have access to the correct or most up-to-date standards, and they either specify over-engineered, which increases part costs and lead time, or they end up actually selecting the wrong part for the application. Even purchasing often struggles to actually procure the item. So typically, the design engineer will know that they want to use something like a hex bolt. So this standard will govern the dimensional characteristics of the hex bolt. But if they're interested in the thread, they're going to have to look at another standard. If they're interested in how you would gauge that thread, they're going to have to look at a different standard. When they want to look at the mechanical properties of this part, its proof at low yield, yield strength, they're going to have to look at another standard. If how they can test the part to make sure it works in the application and make sure it's conforming, they're going to have to look at another standard. When they start thinking about environmental considerations, they're going to have to look at another standard for what the appropriate coding is and how to specify that. And then, while thinking about the application, they're going to have to look in their machinery handbook to see what the K factor is, the coefficient of friction, so that they can then calculate the tightening torque from a formula. So the design engineer has to go through a very lengthy process to specify the correct mechanical fastener for the application. We have SME standards here, so that's the Society for Testing and Materials. We have ANSI, which is the American National Standards Institute. With ASME standards, the American Society of Mechanical Engineers, and we have the SAE, Society of Automotive Engineering standards as well. So each engineer has access to all of these standards. They're going to spend a lot of time reading them to make sure that they are specifying the correct items. On the mech side, things are a little bit simpler because everything is unified under the ISO standards, but you're still through exactly the same number of steps to make sure that you're specifying the correct part. So let's see what the IFI technology does overcome that issue. So if we go into the specialty bolt website, wait for that. And then we click on client login. I logged in as myself. You'll need an email and a password approved. Very interested in the IFI Technology Connection. So if I click the second button here, we get the IFI Technology Connection website. So we were talking about how we come up with custom mechanical fastener specifications. So if we take the example of the English hex head bolt, have a look at a hex cap screw. This is the part looking for. Two different profiles depending if it's machined with a cut thread. The shank diameter is slightly different from if it's a rod thread. But that's the part that we're looking for. And basically through a whole series of pull downs, depending on what material, what grade of material we select, we select SAE J49 grade 5, it's going to look at the database and it's going to kind of give us the available options for off-the-shelf standard parts. So if we look at size, we go for a 1/4 inch diameter. We have fine thread or coarse thread. We'll go for a coarse thread. We have the thread class. We'll go for a plated 2A. We'll go for a 1-inch long bolt. This is extremely useful. We have a whole series of different coatings and platings that are available, and this is very important in terms of obviously the corrosion performance of the part, but also the coefficient of friction in calculating the tightening torque. So if we select a RoHS compliant zinc CI, we can specification. I download that as a PDF, which is a little bit easier to view. And there, we have the illustration that comes directly from the standard that we're interested in, which is ASME B 18.2.1. It's the most up-to-date standard. Everything is updated within 2 days of a new standard being issued. But this is telling me that this part will have a marking of 3 stakes to represent a grade 5. The first section is all about the thread that's governed by ASME B 1.1. It's telling me the major diameter. It's telling me the thread class. This is very important. It's telling me the tensile stress area. The fact that it's coarse thread or fine thread would change the cross section of the minor diameter where the thread is, and that's where obviously the part should break under excessive load. So that it will give me the exact tensile strength. I don't have to look that up in tables. It's telling me that I specified the tolerance that's allowable, giving me the pitch and final diameter, giving me the dimensional data that I might need for the application or some quality might need to see. It's telling me all the dimensions being called out, the E dimension, the body diameter, the shank here. It's telling me how the thread terminates. It's a chamfered end. A lot of very good data here. It's telling me that the part is fully threaded because it's only 1 inch long. If it was a little bit longer, we would have the shank here. We have LB and LG being defined. So we have the thread data. We have dimensional data that's coming from B 18.2.1. We then have the chemical and mechanical information. This is the allowable materials that can be used by the manufacturer to make this part. It's a medium carbon steel because it's relatively strong. So looking at 10.28 through a 10.55 is allowed. That gets you the grade 5. Mechanical material properties are coming from J429. Again, it's the most up-to-date standard. From standard, it's telling me what the hardness should be on the Rockwell C scale, what the proof is, what the yield strength is, and defining it as pounds per square inch. But obviously, because we know what the tensile stress area is, the system can calculate what the proof load and tensile strength is for this coarse thread inch thread would be. We have shear strength, the body, and then through the threads, which is good to know. And then we have the information on the plating. And as I said before, we get the K factor, which is the coefficient of friction. So this is basically how much energy is being lost to heat, and how much of it is actually going into the clamp load. And the reason why the K factor of the plating is important is because it changes the tightening torque. If you have an extremely rough finish, a lot of the energy is going to go into friction. If you have an extremely smooth surface, you don't lose so much energy into friction, it goes into the clamp load. So it changes the tightening torque that you need to apply on this part to achieve the proof load, the clamp load that you're looking for. So you this PDF, you have all the information from all those different standards that we looked at before. You can give this to purchasing. This tells them everything that they would need to provide to SPS to correctly source it. It's good information for the production engineers, so when this part gets to the assembly line, they know what's the maximum tightening torque or running tightening torque given that it's a grade 5, given that it's a 1/4 inch diameter. And it's very, and some companies generate these PDFs, and then this becomes part number 1, 2, 3, 4. They don't create a drawing or any other notation to control this document going forward. It's always best for design engineers to use standard parts. The cost is lower, the quality tends to be better, and the lead time is shorter. So it really is a win-win. The IFI technology connection also has a very good resources, can do exactly the same thing in metric, so go through exactly the same process, and we'll look at have a look at the hex head. Let's have a look at let's have an ICE. So we got ASME that's being phased out. That's the North American standard. We have DIN, which is being phased out, and then we have the ISO standards. But if we look at a hex head here, right to the part we were just looking at before, notation is slightly different because it's from the ISO standard. But again, we use a series of pull downs. Last time we were looking at a grade 5, so that's roughly equivalent to like an maybe a 10.9 for ISO 898. Let's have a look at 6. That would be equivalent to that quarter inch we were looking at before. We go for a 1 millimeter pitch. We go 60 after plating. Length of 25 millimeters. We can select another coding, something a little bit more exotic, maybe a GAC ML. That's pretty common. Generate the specification. We'll do a PDF. Let's have a look. So again, we have the form from ISO 4014, which governs the dimensional data. We have the thread data here coming from ISO 965. Exact information, the only difference that it's metric. We have hardness. We have the materials that the part can be used from. Here you see that the K factor for Geo Black compared to clear zinc is different, so then I have a big impact on tightening torque. Tightening torque is in foot-pounds, but also we have a Newton meter already converted. So this is really the great benefit of the IFI Technology Connection website. It takes away from needing to go to all these different standards to make sure that we're specifying the correct part and understanding what we are specifying. And just through the base, it steers us between what is available by that standard. And one of the nice things is that you generate the PDF. Through the series of pull downs, you can see what the tensile strength of the part is. You can see whether that works in your application or not. If you need something of higher performance, you need something higher than 1,000 million pascals, then maybe you start thinking about a class, probably class 12.9, or you might think about having a larger diameter. So it's a very quick way of changing the sizing and the property class to make sure that you're getting the strength and the tensile strength that you need based on the safety factors that you're using. The real great benefit of the IFI Technology Connection, but there's some other good stuff here. There's chemical requirements. If we look at, we go back to the J429, and we look at grade 8, it will specify materials are required to meet that material standard. The typical designations by the standards that you should be seeing on the certs to make sure that it's conforming. And then when you look at the chemical breakdown, the carbon content, the phosphorus content, the sulfur, the heating, the fact that it had to be quenched in temper to achieve grade 8. So the core requirements is extremely good. Often we have standards where there's a list for a Japanese standard, and it's not being manufactured in Japan. So this will give you conversion to all the other major markets for metals. So you can do a quick conversion to make sure that the is the same. We have fastener weights, which is very useful if you're trying to calculate freight or sizes of bin. We have inspection sizes for quality people. We have testing requirements, which is extremely good. If we look at what's common, we we look at socket set screws, ASTM F912 is telling that you're going to be testing to ASTM F606. That will give you tensile, that will give you the ISOD test, all requirements that are required to the socket set screw is conforming. We have locking performance for insert lock nuts, IFI 124, so that's nylon patches. It will tell you what the prevailing torque needs to be, what the clamp load is, verify that, Scotch grip, ND microspheres, nylon patches, non-insert lock nuts are all conforming. If you do a lot with tapping holes, very good resource for working out the correct application size depending on what material you're going into, the thickness, and it will give you recommendations in terms of drill size you should be using, that you need to get, and the engagement and the recommended screw type to engage into that tapped hole. A really good wealth of information. You have the finishes. There's two ways of using this. One way is if you know of a finish or you're researching a finish, you can just select it. So if we look at mechanical zinc, relatively thin application, it will again, I can create a PDF. It will tell me what the coefficient of friction is. It will tell me whether it's RoHS compliant. It will tell me the thickness requirements, both in inches and in metric. It will tell me the color, and it will tell me the type to go to red rust and white rust to base the standard of the plating. Another way you can use it, if you don't know what plating or coating you're thinking of, you can simply, okay, yeah, I need a RoHS compliant plating because my product's going to Europe. I'd like it to be black, to be at least 100 hours in the salt spray before we see any corrosion, and the database will spit out the platings and the coatings which are compliant with those three criteria. And then we can just click on one to do a little bit more research, and we can write the specification. So we can on file that this is the coating that meets our requirements, and I'm going to have to specify that it's going to be at least 10 microns thick, and I want somebody to verify that it's at 120 hours before red rust, and it also meets an automotive standard here. So really a huge amount of data to play around with, and then there's a very good technical library here. Especially on corrosion is extremely good, hydrogen embrittlement, the manufacturing of parts, selling into Europe, REACH compliance is very important, and we have a whole series of very good articles that you can view, download, and keep on file, but be re-educated in the world of mechanical fasteners. So this is the IFI Technology Connection website. It's freely accessible through the SBS website. I hope this video was helpful. If you have any questions, please let me know, and we can always set up a demonstration either in person or via WebEx. Thank you.